So let's look at another example. Let's look at the closing prices of stocks. In this example, you can see here that the closing prices of stocks has a slightly right skewed distribution. So you can see that just by, if you wanted to actually draw a line, you can see that it's skewed to the right. It has a population mean of 26 and a standard deviation of 20. And the question is, what is the probability of randomly selecting a closing stock whose value is less than $15? So we're talking about what's the probability of selecting something that's somewhere around here. So the question is, well, there's a few questions. First of all, what's the distribution of the closing stock prices? Well, we know that the distribution is skewed. And it's skewed right. The second question is, should we use a z-score in order to figure out this probability? So should we use P where x is greater than, is less than, let me erase that, is less than $15? Well, the answer is a resounding no. And the answer is no, because this distribution is not normal. We can only use this method when the distribution is normal. Now, if we had a sample size, if we looked at a sampling of distributions, so a sampling of the means, then the means of the sample, then we could actually, and we had a sample size that was big enough, we could actually make this more normal in distribution, and then we could actually calculate some of these probabilities. So the magic number to remember here is if you have a sample size and it's 30 or higher, that is a good sample size to have to make your distribution more normal, or to normalize the distribution.